It was in the homework, actually. The pH and pK one.
So hang on one second. Hi, Sarah. Can you hear me? Oh, now you're connected to audio. Can you hear me? Oh, okay. Well, right now it's just you, and there's nobody here in person. So I'm going to keep recording this. I'm actually outside my office, kind of in the hallway. But did you want to work on naming? Is that what you kind of want to continue to practice? All right. So, and this will work because I'm going to record this so that it's something that other students can kind of watch later. So why don't we just plan on, do you still have the copy of what we had with, I guess it was the packet we were working on in class on Wednesday. So we only got through 2 pages of that. So we got 3 other pages. That was my plan for today, was nomenclatures, to continue to work through those 3 other pages. I don't think I had posted the solution yet for that because I wanted to kind of save it to work on today. So do you have that packet? All right, perfect. Why don't you start working on page number 3, and then post questions in the chat if you have them. I'm just going to kind of let you work on it for a little bit. And then what I'm going to do is I'm going to grab my iPad. I'm going to hook up my iPad so that we can sort of walk through solutions. You can check your answers to that. I'll probably walk through each problem so that anybody who's watching this later has an opportunity to kind of see that. And then after that's done here, I'll also post that key to Teams, but I was hesitant to post it before we had this session because I kind of wanted to give people an opportunity to practice it genuinely. So any other questions before I kind of let you work on that for a little bit? All right, so you work on this for a little bit. I'm going to mute my audio and video here. I'm going to hook up my iPad so you'll see that come online in a second. And then you can let me know when you're ready to maybe go through that 3rd page. I'll kind of rely, since you're the only one here right now, as soon as you're ready to kind of check your answers or see things, you can just let me know in the chat and we'll start going through it. Okay. Hi, Sarah. I just see that you finished the third page. So give me 1 second. I'm just hooking up my iPad and then we can go through the solutions. All right, Sarah, I think this is the third page that you were working on. Can you just let me know in the chat if this is the page you were on? Perfect. All right. So again, I'm just going to walk through these. And then when I get through them, I'll pause for a second and so you can just put in the chat if you have any questions on any of them. So, and there's a couple of them that I've sort of circled if I sort of felt like maybe they were ones that I wouldn't ask if they were a little bit too difficult or a little obscure. And this first one happens to be one of them, tellurium trioxide. So based on where tellurium is, it's sort of in that metalloid category, but this is going to be a covalent compound. So we need to name it as tellurium trioxide. And then here we have carbon disulfide. And reminding, I'm going to remind people too, going in this direction is actually the lesser of the important ways. Let me turn on my video here so you can see me as well. So this is not as important as going in the opposite direction. Are you all?
We're coming back.
You're coming back?
We're
Okay.
taking a little break.
You're fine. You're fine. So not as important as going in the other direction where you're actually writing a chemical formula. And to highlight why that's important, going in this direction where you make a chemical formula is important because what you will be then using that chemical formula for is writing a balanced chemical equation or kind of having a situation where you're going to do something with that correct chemical equation. Okay, so that's what we're going to be using that for. All right, so moving on, we've got iron 3 hydroxide. So you could also call this ferric hydroxide. So remember, there's like 6 or 7 of those that it's important to know the kind of common names of as well. Then we've got calcium oxide. This one is another covalent compound, so we need to use those Greek prefixes, tetraphosphorus triselenide. We see a lot of vanadium compounds here. This is going to be vanadium 3 sulfide. Copper 2 sulfate, you could also call this cupric sulfate. A couple of polyatomic ions here for ammonium phosphate. Then we're going to have cadmium 4 fluoride. And then sodium nitrite. So highlighting again that spelling and making sure that I can see proper spelling is going to be really important for this quiz so that I can give full credit. So let me go through the bottom part here. And then Sarah, I'll see if you have any questions. And if not, then we can move on to the 4th page there. So another, again, this is the more important skill, is being able to take a name in words and generate a chemical formula for it. So bromine pentachloride is BrCl5. Tetraphosphorus trisulfide is P4S3. Lithium acetate. So remember, the way that I tend to do these problems is I write what the pieces are, and then we can use the crossover approach if it is an ionic compound to find the ratio of cations to anions. Highlighting and remembering with a covalent compound, we won't use the crossover approach and simplify those because covalent compounds indicate the number of specific atoms that we have in that molecule. Then we've got zinc phosphide, so that's going to be ZnP2, barium nitride, Ba3N2, strontium chloride, SrCl2, arsenic pentafluoride. So again, we know that that's a covalent compound because we can see the Greek letters that we have there. Aluminum hydroxide, so AlOH3. Then we're going to have cobalt-3 carbonate. And then the last one here is manganese 2 bicarbonate. Also noting that you could see this as hydrogen carbonate. That's also an acceptable name for that polyatomic ion. So I'm going to pause there for a second, Sarah, see if you have any questions on those guys. All right, very good. All right, so let's just move on to page 4. I did have a student kind of show up here in person, so I'm going to mute myself and stop the video, and we'll work on page 4. And why don't you let me know when you're done, and then I'll see where I'm at with this this student here. All right, Sarah, I see you finished the fourth page here. So what I'm going to do is go ahead and go through that. And then we'll have you kind of working on the fifth page. So let me get my video going here. Grab my iPad. All right.
Jack's hard to find sometimes.
Oops. Hang on there. All right. So with these ones, and I commented on a couple of these, we're actually going to get to some of these ones in class tomorrow. So hopefully these ones will be a little bit easier and make more sense once we do them in class. But some of these that we find in their elemental state, we just call them what the element is. There's not really a naming sort of piece to it. It's just like if I were to write, sodium as a sodium metal, it would just be Na. So that's what some of these are. Even though it's a covalent compound, that's how it's found in its elemental form. So we saw fluorine before with this. Now we see bromine. So I'm going to revisit those tomorrow in class for some of the compounds that we're going to see there. Let's see, hopefully my video is still okay here. It's saying my internet connection is unstable. So hopefully we're okay there. Next guy here is ammonium sulfate. And then we're going to have nitrous acid. So I'm going to take a second here and just highlight some important things with acids, because I know acids can get really confusing. So the first thing you want to make sure you do, especially if you're naming an acid, clearly if we're working in the other direction, you see that it has acid probably in the name. So how do you know that I have an acid? Well, you usually see at least one hydrogen that starts the compound. That's a clue that you have an acid. So what you need to do then is you need to remove the hydrogens, and then you're going to look at the anion that's left. We'll learn about this later, but that's actually called the conjugate base. So you're going to say what's left after I take the hydrogens away is NO2 minus. Now then you name that polyatomic ion. That polyatomic ion is called nitrite. Anything that ends in ITE, that ITE comes off and gets replaced by OUS. And so this generates nitrous acid. So that's how you'd name HNO2 as an acid. Okay, next guy is lead 4 carbonate. And we've got another covalent compound here. So we need to use Greek prefixes to tell us how many of each species we have. This is dinitrogen monoxide. Then we're going to have zinc fluoride. Another covalent compound, carbon tetrafluoride. This guy, again, I was just kind of highlighting, is a little bit different. This could be named a couple of ways, and that's why I've got it circled here. You could name this as an acid. You could call it hydrosulfuric acid, or you could name it as the covalent compound dihydrogen sulfide. Okay, so that's what that guy is.
That's exactly what I'm thinking about.
So I have a student who's working right next to me here, and she's like, I'm on that problem, and I was confused about that one, but I think maybe we addressed that problem there. We've got this guy, which is going to be aluminum hydroxide. And then our last guy here is potassium oxide. Okay, so that's those. And Sarah, I don't see that you have any questions yet in the chat about those. So I'm going to move down to the next group here. Again, highlighting this is the more important piece, is being able to write a correct formula for a name. And this is one where I am going to be super specific, where if you write something that changes, for example, what the identity of the substance is, the number of atoms that you have, if that's not correct, then that's going to be marked wrong. Up top here, for example, if you had something, if I'm trying to think of an example here, like you shouldn't have a Roman numeral 2 there for zinc 2 fluoride, but that doesn't make it into a different substance. It just adds something that's not supposed to be there. I'm going to be more generous going in this direction than I will be if you have something in this bottom section, for example, where you write a chemical formula that is not the right substance, okay, because that's going to be the important way moving forward. So our first guy here, covalent compound, this is going to be sulfur trioxide as SO3. Tin 2 sulfide is going to be SMS. Here's magnesium acetate. Okay, because magnesium is 2+ and our acetate is -2, we have to have 2 of those big acetate pieces. So all of that needs to go in parentheses. This is another one of these ones that's a little bit challenging. If we had just phosphoric acid, and I think I might have mentioned this one in class on Wednesday, if we just had phosphoric acid, this is phosphoric acid. Taking an acid, we would take off all the H's and we'd look at the polyatomic ion that's left over. That was phosphate. And so when we have either the phosphorus or the sulfur pieces, like sulfate or phosphate, when we create the ic piece, the suffix become phosphor or sulfur. So we have, it's sulfate as the polyatomic ion, but it would be sulfur as the prefix. We actually have to add a little bit to the prefix there, which can be a little bit challenging. But again, I'm going to be a little bit more generous when you are providing me the written name versus the chemical formula. So for this guy, just highlighting, if it was just phosphoric acid, that's what it would be. Because we have this hydro in front, having that hydro in front is something that is reminding us that this is what we call a binary acid. It's going to have just hydrogen with some specific element, okay? So in this case, that means it's not phosphate as a polyatomic ion, it's just phosphorus as we would find it just as a P. So if we're finding phosphorus as an anion, it's going to be 3-. And so to have enough hydrogens with it, to have it be a neutral compound, that's going to be H3P. So that's a tough one, okay? Looking at the difference between phosphoric acid and hydrophosphoric acid. But looking at that hydro, if you see the hydro at the beginning, think about things that you maybe are familiar with, like hydrochloric acid. Okay, that's another binary acid. That's H and then just Cl. Cadmium chloride is going to be CdCl2. Iron 3 phosphate, it's going to be FePO4. Those are both 3+ and 3-, so that's a 1-to-1 ratio. Dinitrogen trioxide, N2O3. Here's our elemental fluorine again, so that's going to be F2. You're not likely, I shouldn't say not likely, you won't see something on your quiz or your exam that sort of has these elemental compounds that we're naming, okay? Those are going to be kind of what we reserve for doing some stuff with later. Another vanadium compound, vanadium 5 bicarbonate. That's going to be 5 of those bicarbonate ions. So we have that subscript 5 there. And then ammonia. Some of these more common compounds we're going to actually talk about tomorrow in class. So ammonia here is going to be NH3. So I'll pause there for a second. Sarah, I don't see you have any questions in the chat, but I'll see if there's anything you want to ask about before we move on to page 5. All right, well, very good. So again, the nice thing, if you're watching this as a video, before you listen to the answers, you certainly can pause it for as long or as short as you need to work on the problem before we kind of have the solution revealed here. All right, so I'm gonna let you guys go and start working on the last page that we have here, which is page 5. And then Sarah, if you wanna let me know when you're done, I'll start going through the solutions. All right, Sarah, I see that you are finished with page 5. So I'm going to kind of walk through the solutions for it here. We'll see if you have any questions. And then I didn't have, I mean, we've been doing nomenclature practice a lot. I'm going to circulate right after we're done here. I've got a study guide. I've been in lab all day, so I haven't had a chance to post it yet. But I have a study guide that I'm going to post for our first exam, which is next week. So we'll have time during next week's session to kind of work through some more things related to the kinds of problems you're likely to see on the exam. Obviously, naming is going to be a significant chunk of your exam. Good news is that there will be partial credit for any of the problems that you have there. But there's also going to be, doing nuclear equations, writing nuclear equations, thinking about unit conversion. There's several unit conversion problems that are on the exam. So this first exam, being units 1 and 2, is going to have sort of a mix of different things that we'll have there. So we'll have time to do that during next week Monday's problem solving session. And then remember, next week Monday, you also have your first attempt at quiz here. All right, so let's go through this last page, see if there's any questions that we have here. So we've got calcium hydroxide, we've got barium fluoride, we've got iron 2 nitrate. Remember, if you do not have a Roman numeral when you're supposed to have one, that'll be a problem. You won't get that problem right. So I would actually rather have you make sure that you include it if you're not certain, but do me a favor, don't do it on anything from group 1 and group 2. I want you to know that group 1, that's on that first part of the periodic table, potassium, sodium, things like that. Don't ever write a Roman numeral with those or anything in group 2. So calcium, magnesium, strontium, those are always going to be our +2 cations. Don't put a Roman numeral with those. But if you happen to put a Roman numeral with something that's in the middle of the periodic table, those transition elements, and it's something that doesn't need one, I'm not going to take off points for that because it doesn't make it wrong. It just provides information that's not necessary. Okay, so this case, we've got iron 2 nitrate. We've got carbon tetrafluoride, another covalent compound, dinitrogen trioxide. Here we've got another acid here. So remember, when we have an acid, what you want, it's an acid because it starts with H. So take the H off and look at the anion that's left. It's going to be a polyatomic ion. So name that polyatomic ion. In this case, it's nitrate. Anything that's ATE becomes IC. So that's going to be nitric acid. I'm going to flip over just for a second here to a page that we have here. Not there, right here. So one of the videos that I have out kind of walks through all the kinds of different possible naming you might see, from simple ionic compounds to thinking about things that are multivalent metals to polyatomic ions. We haven't talked about this much, but you might see something that is a hydrate. Okay, so that's going to have some water molecules with it, and we use Greek prefixes to tell us how many water molecules we have. So we haven't really seen ones to practice with that. So I wanted to make sure to point that out. And we talk about covalent compounds. We've really only seen binary covalent compounds, meaning there's only 2 elements that we have with it, but it might be something that you need to use those Greek prefixes for again. And then we've got acids here, reminding you that the acids on your quiz are only going to be on the first in-person in-class quiz, and these will be extra credit. So if you want, make sure look through this video. I have it posted under the naming section. This is going to be one that kind of walks through and helps categorize and maybe provides a good study guide for how to know all of the different multivalent metals. So that's what we've got here. It walks through kind of these polyatomic ions that have different numbers of oxygen atoms. So there's the oxyhalide series, and then we've got these oxygen polyatomics that are either the nitrogen-based ones, the carbon-based ones, sulfur, and then phosphorus-based ones. So those are ones that can get a little bit confusing, and so those are all kind of categorized there. And then importantly, why I wanted to put this slide up real quick, since we were just naming an acid, reminding us that after you go and find out all of these guys that are polyatomic anions, If you mix them with a hydrogen atom, that's going to generate an acid. Remember, you have to mix them with the number of hydrogen atoms that will give you a net charge of 0. So it might only be one hydrogen atom here. In this case, it's going to be two hydrogen atoms, or in this case, 3 hydrogen atoms to make those be neutral. Okay, but here's the important part for naming acids. Once you figure out what the polyatomic ion is, if the polyatomic ion ends in ITE, you're going to take sort of the prefix that we have here, and then you're going to add OUS. And then if it's the ATE, you're going to add IC. I should actually add something here. I'm noticing here that I've got the sulf prefix because that's what we have here. We should note that you actually need to make this be sulfur and then phosphor. So we actually need to add a couple of other letters if we're naming, okay? So, oh, I guess I do have it right here. I didn't realize. So yeah, the sulf becomes sulfur and the phos becomes phosphor. So it would be, for example, phosphoric acid, even though it came from phosphate. We need to add that OR. So I know acids can be a little bit wonky to name, but that's why they're extra credit. All right, so let me come back here to the problem that we were just working on, which was right here. So this guy right here came from nitrate. So the ATE means it becomes nitric acid. We've got manganese for sulfide. We've got lithium phosphide, copper 2 sulfate, which you could also name as cupric sulfate. Now, if you were using that cupric prefix, you wouldn't want to put the Roman numerals in because that cupric versus cuprous tells us that it's +2 and not +1. Then we've got methane. This is another one of these common name ones. We're going to learn more about these common small molecules tomorrow when we learn how to draw them. You could actually also call this carbon tetrahydride if you wanted to. Last group here, kind of giving a chemical formula. We've got copper 1 oxide, which is going to be Cu2O. Potassium cyanide is KCN. Silicon disulfide, SiS2. Phosphorus trioxide, PO3. Now, questions have come up sometimes when students see this, they'll be like, well, wait a minute, if it's PO3, isn't that phosphite and isn't that going to have a -3 charge? Well, nope, that's a polyatomic anion. This is a covalent molecule. So PO3 is a covalent molecule. Here's ammonia. Again, we've seen ammonia a couple times in this set of 5 sheets here. Iron 2 phosphate. This is one where we want to do the crossover approach so that we know that we're going to need 2 phosphates and then 3 irons to have that be charge net neutral. Here's hydrobromic acid. Remember, here's that prefix hydro. Hydro reminds us that it's going to be a binary acid. So it's hydrogen with kind of one other species. And so in this case, it's bromine, which is going to be bromide as an anion. So that becomes hydrobromic acid. Magnesium nitrite, okay, Mg, and nitrite is NO2-. We need 2 of those to balance charge. We've got ammonium nitride. So nitride is different from nitrite. So that's just a nitrogen atom with a -3 charge. And last one to round out this list is gallium trichloride. Okay, so I'm going to pause there for a second. Sarah, I'm going to see if you have any questions. And honestly, that's all I have I don't have any extra problems to work on. We've sort of worked on a lot. I'm happy to kind of stick around if you have any other questions. You're welcome, Sarah. But if you don't have anything else and it seems like, you know, you're working through these problems fine, that's all I have for this week's class. We're certainly going to have a lot for next week's problem solving session since we'll have all of unit 1 and 2 to work on and practice in preparation for the exam on Friday. All right, thanks, Sarah. We'll see you. I'm going to stop recording this session, so it'll be a little bit of a shorter session that we'll sort of post here. But that's all that we're going to have for today. I'll still be here for a little bit longer to work with some people who are here in person.